In May 1931, a massive dark gray hull slid into the waters of Kiel, Germany. To the tens of thousands of spectators cheering from the slipway, it was a symbol of national rebirth. To the foreign naval attachés watching closely from the docks, it was a mathematical nightmare. A decade earlier, the victorious Allies had built a legal cage specifically designed to render the German fleet permanently harmless. Its tonnage limits appeared to leave Germany too little room for any replacement ship capable of challenging the great naval powers on the open ocean. Instead, the German Navy used the exact rules of that treaty as a weapon. They had engineered a ship entirely outside the conventional boundaries of naval architecture. It was a vessel built around a ruthless tactical ambition: outgun the ordinary cruisers fast enough to pursue it, and outrun the slower battleships powerful enough to destroy it. Fast battle cruisers remained a deadly exception. The British press, searching for a way to categorize a threat that simply should not exist, quickly dubbed it a pocket battleship. The launch of the Deutschland did not just shock the world's admiralties. It proved that arbitrary legal limits do not create disarmament. They force radical innovation. But how did a nearly bankrupt navy, constrained by some of the harshest military restrictions imposed after the First World War, manage to build a machine that forced Europe's admiralties to rethink the naval equation? The answer begins in 1919, when the Allies thought they had frozen German naval capability forever. To understand the shock of 1931, you have to understand the humiliation of 1919. At the end of the First World War, the Imperial German Navy, once the second most powerful fleet on Earth, had essentially ceased to exist. Its modern dreadnoughts had been scuttled, its submarines confiscated, and its maritime ambitions entirely crushed. The naval clauses of the Treaty of Versailles left the new Weimar Republic with a museum fleet. The newly reformed Reichsmarine was permitted to keep just a handful of obsolete pre-dreadnought battleships. These were coal-burning relics that posed absolutely no threat to the victorious Allied powers. But ships rust, and even the treaty drafters recognized that eventually these antiques would need to be replaced. When they were, the legal limits were absolute. No replacement armored ship could displace more than 10,000 long tons. The treaty imposed no separate maximum caliber on these replacement armored ships. The decisive formal constraint was displacement. This was not just a restriction, it was a strategic trap. The Allies used tonnage limits as a tool of strategic suppression. In the naval architecture of the 1920s, 10,000 tons was simply not enough mass to build a viable capital ship. A true battleship of the era weighed between 25,000 and 35,000 tons. To fit a ship within a 10,000-ton limit, a designer had to balance a brutal equation involving firepower, armor, and the massive steam machinery required for high speed. You could have one or two of these attributes, but physics dictated you could never have all three. The Allied authors of the treaty knew this mathematics perfectly well. They assumed Germany would be forced toward a slow, heavily armed coastal defense ship with limited range. Such a vessel could guard a harbor, but it could not protect merchant shipping, project influence, or break into the Atlantic to threaten British or French trade. During the first half of the 1920s, German planners explored several replacement concepts, including slow, heavily protected coastal defense ships. But the studies never followed one simple, settled line. The construction department kept shifting the balance among armor, speed, and armament as Germany's strategic priorities evolved. The restrictions appeared to have contained German sea power. But in 1924, Admiral Hans Zenker became chief of the Naval Command and gave new force to a debate already underway inside the Reichsmarine. A veteran officer who had commanded the battlecruiser Von der Tann at the Battle of Jutland, Zenker favored concepts that offered Germany more than passive coastal defense. Under his leadership, staff exercises, strategic studies, and construction work increasingly turned toward a faster, longer-ranged armored ship. Zenker realized that building a heavily armored, sluggish ship merely to defend the Baltic Sea against secondary powers was a waste of Germany's strictly limited tonnage. A coastal defender could be blockaded or ignored by a larger adversary. Zenker became a powerful advocate for a faster, longer-ranged armored ship, although the final concept emerged through broader staff debates and design studies. Long range would let it operate beyond the Baltic and threaten an enemy's sea communications, including merchant traffic. The precise doctrine was still evolving, but passive coastal defense was no longer enough. To survive as a lone raider, Zenker defined a brutal, binary tactical requirement. The ship must be fast enough to outrun any existing dreadnought, and heavily armed enough to outgun any cruiser fast enough to catch it. In the 1920s, global warships fell into strict categories. Many older battleships carried massive firepower, but moved at roughly 21 knots. Treaty cruisers could exceed 30 knots, but their main batteries were generally limited to 8-inch guns. Between them stood a dangerous exception, the battlecruiser, fast enough to pursue the German ship and powerful enough to destroy it. Zenker intended to build a ship that lived precisely in the lethal gap between them. The emerging design aimed at roughly 28 knots and selected 28-centimeter, or 11-inch, main guns, the heaviest battery the designers believed they could fit within the ship's unforgiving weight equation. This was the moment the equation of weight became a crisis. Asking for battleship-caliber artillery and cruiser-level speed on a hull legally capped at 10,000 tons was considered a mathematical impossibility by conventional engineering standards. A single 11-inch gun turret, complete with its armored barbette and mechanical hoists, weighed roughly 600 tons. High-speed steam machinery required massive, heavy boiler rooms. Zenker was a strategic champion, not a naval architect. He did not tell his designers how to manipulate the physics. He merely dictated the requirement. When the Naval Construction Department warned that something had to give, Zenker held firm to the speed and the firepower. If heavy armor had to be sacrificed to balance the scales, so be it. The ship would use its speed to dictate the terms of engagement, choosing when to fight and when to flee. Zenker had helped establish the strategic direction, but before the ship could be built, the Navy had to survive a political fight over money in the anti-militarist Weimar Republic. At the same time, a separate network of secret naval financing was moving through the shadows, a scandal that would destroy Zenker's career. In the mid-1920s, the Weimar Republic was a fragile democracy scarred by hyperinflation, severe economic instability, and deep political division. Within this climate, asking the civilian parliament, the Reichstag, to fund a staggeringly expensive, radically unproven warship was practically impossible. The Social Democratic Party, the SPD, vehemently opposed any naval rearmament that threatened to drain the national treasury. Their political rallying cry during elections became famous: Panzerschiff A oder Kinderspeisung, Armored Ship A, or Food for Children. The political reality dictated a harsh engineering constraint. Developing a warship entirely outside standard architectural boundaries required immense research and development. The Navy needed to test entirely new metallurgy, fund engine prototypes, and design experimental weapon mountings. Because of the intense political hostility, the Navy knew they could not return to a hostile parliament to ask for budget overruns if the design failed. The engineering had to be funded up front, and it had to work on the first try. To shield this expensive R&D from civilian oversight, the Naval Command turned to the shadows. Captain Walter Lohmann ran the Navy's Sea Transport Section, but his true function was acting as its secret financier. Using funds illicitly diverted from government accounts and the clandestine sale of scrap materials, Lohmann built a shadow financial empire consisting of dummy corporations, film companies, and commercial shipping lines. Lohmann's hidden funds supported a broad range of clandestine naval projects without normal parliamentary scrutiny. They formed part of the secret rearmament environment surrounding the Reichsmarine. But surviving evidence does not prove that this black budget directly financed the decisive research for Panzerschiff A. But secret empires are fragile. In the fall of 1927, investigative journalists uncovered Lohmann's illicit network. The resulting explosion, known as the Lohmann Affair, shook the foundations of the Weimar government. It was a massive institutional crisis. The revelation that the military was operating a shadow budget behind the backs of the elected parliament outraged the German public and gave the anti-militarist factions a powerful weapon. The political blowback was swift and brutal. Defense Minister Otto Gessler resigned in January 1928, and in September, Gessler's successor Wilhelm Groener dismissed Admiral Hans Zenker. The scandal had destroyed confidence in the naval leadership, but there is no firm evidence that Zenker was deliberately sacrificed in a bargain to save Panzerschiff A. Yet the greatest political irony concerned the ultimate fate of the ship itself. In March 1928, before the national election, the Reichstag approved a budget containing the first construction funds, although the Reichsrat urged the government to delay any start until the financial position had been reviewed. The SPD then emerged as the largest party after campaigning against the ship. Once Hermann Müller's coalition took office, it faced the explosive question of whether to reverse an already authorized program. Under pressure from the military, the coalition partners, and President Hindenburg, the cabinet approved the first construction installment on August 10th. When the SPD parliamentary group later tried to halt the project, the Reichstag rejected the motion in November. Zenker was gone, dismissed from the Navy just months before Panzerschiff A was laid down. But surviving Parliament was only the first hurdle. The burden now shifted to the designers of the Naval Construction Department. They had their money, but still had to figure out how to build the mathematical impossibility. The requirement Admiral Hans Zenker left behind now passed to Paul Press, chief constructor in the Naval Construction Department, or K-Amt. To reach 28 knots while carrying 6 11-inch guns on a legally constrained 10,000-ton hull, Press's team had to reconsider every major component of standard naval architecture. The first major variable in this weight equation was firepower. Traditional capital ships distributed their main battery across 3 or 4 turrets to ensure that a single enemy shell could not disable the vessel's entire offensive capability. But every turret required a massive armored barbette extending deep into the hull, along with its own heavy mechanical ammunition hoists and rotating machinery. Press's team chose a radical, highly risky concentration. Pushing 6 massive guns into just 2 triple turrets, one placed forward, one aft, saved the heavy steel footprint of a 3rd armored barbette. The mathematical advantage was profound, but the cost was sheer tactical vulnerability. A single lucky hit in combat could wipe out half the ship's firepower in an instant. Even with the turret compromise, the theoretical hull remained desperately overweight. The K-Amt therefore adopted extensive electric arc welding, reducing the weight of overlapping plates, straps, and fasteners required by a riveted structure. The savings created room for the guns, but the method introduced significant industrial risk. Structural welding on this scale demanded skilled labor, careful inspection, and strict quality control to prevent defective joints or fatigue cracking at sea. The final piece of the engineering puzzle was propulsion. Zenker's vision of a lone wolf commerce raider demanded unprecedented operational endurance. Traditional boiler and turbine plants demanded large machinery spaces, heavy boilers and condensers, substantial fuel reserves, and more time to raise steam from a cold condition. To solve this, the K-Amt partnered with the specialist engineers at MAN, or Maschinenfabrik Augsburg-Nürnberg. Their choice was revolutionary. The ship would be the first major surface warship powered entirely by marine diesel engines. 8 massive MAN diesels were grouped together in a highly complex unit machinery arrangement to drive the 2 propeller shafts. Steam turbines required heavy boilers. Diesels did not. This gave the ship a range of roughly 10,000 nautical miles at economical cruising speed, dramatically reducing the frequency of refueling and allowing it to operate across enormous stretches of ocean. But extended ratings still depended on supply ships for fuel, provisions, maintenance, and other consumables. Furthermore, diesels offered a valuable tactical advantage for a raider. They could be brought into operation and adjusted more rapidly than a completely cold steam plant. They did not, however, transform a cold and unprepared warship into a 28-knot ship within a few effortless minutes. But this innovation held a mechanical cost. The enormous diesels produced severe vibration, enough for the Navy to commission studies of its effects on the welded hull and sensitive fire control equipment. Deutschland required reinforcement and other modifications to bring the problem under control. What the surviving evidence does not establish is a simple line from engine vibration to optical failure in battle. Furthermore, even with the tonnage saved by welding and diesels, there was simply not enough mass left for true dreadnought protection. The armored citadel guarded the machinery and magazines, but large areas of the hull and superstructure remained vulnerable to sustained cruiser fire. Paul Press and the engineers at MAN had produced a workable ship through severe compromises in turret arrangement, structural weight, armor, and diesel propulsion. In early 1929, the final plans were sent to the Deutsche Werke shipyard in Kiel. Theory was about to become steel. On February 5, 1929, the keel of Panzerschiff A was laid down at the Deutsche Werke shipyard in Kiel. For the next 2 years, a highly skilled labor force wrestled with the radical blueprint they had been handed. Fusing the massive steel hull plates with electric arc welding, rather than traditional rivets, was a slow, painstaking process. Extensive X-ray inspections were required to ensure the welds were flawless, as a single structural failure in the violent swells of the North Atlantic could doom the vessel. On May 19, 1931, construction reached its first public climax. The launch of the newly christened Deutschland was a meticulously choreographed national spectacle. Over 60,000 spectators lined the slipways, roaring with approval as President Paul von Hindenburg presided over the ceremony. After years of post-war humiliation, crippling economic depression, and the bitter political scandals that had forced Admiral Hans Zenker out of office, the massive dark gray hull sliding into the Baltic Sea was heralded as a triumph of German resurgence. But beneath the waving flags and the patriotic speeches lay a very deliberate, calculated lie. Officially, the German government declared that Deutschland displaced exactly 10,000 long tons. In reality, the completed ship displaced approximately 10,600 long tons at standard load and more than 14,000 at full load. Standard displacement legitimately excluded fuel and reserve feedwater, but it still included the crew's freshwater, provisions, armament, ammunition, and equipment. Even under that definition, the official figure understated the ship's true displacement. The Navy was also relying on uncertainty. Foreign governments could study the published specifications and observe the ship from outside, but the post-war inspection regime was no longer operating in the manner this deception would have required. Germany's official figure concealed the excess, and outsiders initially lacked a dependable way to determine the completed ship's true standard displacement. When the official specifications were published, the reaction in foreign admiralties bordered on panic. A vessel claiming a 10,000 nautical mile range, 28-knot speed, and 611-inch guns appeared to leave existing fleets without an easy conventional counter. British and French planners now had to reconsider how their cruisers and battleships could intercept it. It was an entirely new, highly specialized machine that had exploited the very legal framework designed to prevent its existence. The world marveled at its paper specifications and the audacious engineering that made it possible. But warships are not fought on paper, nor do they wage war in the press. The Deutschland and its sister ships were about to meet the brutal reality of the open ocean, where the hidden costs of the weight equation would finally come due. When the Second World War erupted in 1939, Deutschland and Admiral Graf Spee had already been positioned in the Atlantic. Admiral Scheer remained in Germany for refit and did not begin her major Atlantic sortie until late 1940. During the first months of war, Graf Spee used the manned diesels and roughly 10,000 nautical mile range to raid merchant shipping across the South Atlantic and Indian Ocean without entering a friendly port. But Zenker's requirement had been written for more than attacks on defenseless freighters. In December 1939, at the Battle of the River Plate off South America, the ship met the kind of cruiser force it had been designed to defeat. The Admiral Graf Spee was intercepted by a British hunting group consisting of one heavy cruiser, HMS Exeter, and two light cruisers, Ajax and Achilles. This was precisely the scenario Zenker had envisioned a decade earlier. Each British cruiser was individually outgunned, but together the three ships brought greater speed, numbers, rate of fire, and combined combat power. The encounter was dangerous for both sides, not a foregone execution of weaker pursuers. Langsdorff initially closed the range, while the faster British cruisers retained the greater ability to control the distance of the engagement. Then, the first serious disruption struck Graf Spee's fire control system. An 8-inch hit cut electrical connections to the principal rangefinder and disrupted the primary fire control arrangement, forcing the gunnery team onto less effective alternatives. The two-turret layout imposed its own tactical strain. Graf Spee could divide her main battery fire, but engaging widely separated targets reduced concentration and complicated the observation of shell splashes. Her secondary guns also joined the fight. When the massive 11-inch guns connected, they were devastating. The Panzerschiff brutalized the heavy cruiser Exeter, wrecking much of its fighting capability and forcing it to withdraw. But then, the final consequence of the weight equation came due. Because the designers had sacrificed heavy battleship protection to pay for guns, machinery, and range, the Panzerschiff could dish out punishment more readily than it could absorb a prolonged crossfire. The armored citadel protected the vital machinery and magazines, but exposed upper works and lightly protected spaces suffered repeated hits. British shells damaged the bow, galleys, secondary weapons, fire control connections, and the plants used to produce fresh water and prepare fuel for the diesels. Published assessments differ over the exact total, so the safest description is that approximately 20 shells struck the ship. Graf Spee had mauled its hunters, but could not absorb the sustained damage and operational losses of the engagement. With damage to the bow, fuel processing, and water-making systems, diminished ammunition, and only limited time in a neutral port, she retreated into Montevideo. British deception magnified Langsdorff's fear that powerful reinforcements were gathering outside the estuary. Convinced that escape was hopeless, he took the ship out on December 17th and scuttled it in shallow water. Graf Spee had reached port under her own power. Her destruction followed only after battle damage, logistics, diplomacy, intelligence, and command judgment converged. Its greatest historical impact lay not in the ships it sank, but in the warships it forced foreign powers to consider building. When the Deutschland first slid into the water in 1931, it did not merely provoke sensational newspaper headlines in Britain, it triggered an absolute strategic panic within the French Admiralty. France relied heavily on its North African empire for resources and manpower, requiring safe passage across the Mediterranean and Atlantic. A long-range German raider with 11-inch guns threatened those routes and exposed a gap in France's existing force structure. To counter the Panzerschiffe, the French Navy concluded that it needed a faster, more powerful capital ship. In 1932, just a year after Deutschland launched, France authorized the Dunkirk class. Designed to hunt the German Panzerschiffe, The new ships paired 30-knot speed and 330mm guns with protection intended to resist 11-inch fire, removing the German design's central tactical advantage. The laying down of Dunkirk created a powerful boomerang effect. Italy's later decision to build the 35,000-ton Littorio class then pushed France toward the larger Richelieu design. But the broader return to capital ship construction had many causes: treaty replacement schedules, Italian policy, Japanese withdrawal from the naval limitation system, German rearmament, and the rapid deterioration of international security. Deutschland was one important catalyst, not the single force that dragged every major navy into a new construction race. France's response showed that the original advantage could not remain uncontested. Against newer, fast capital ships, the Panzerschiff could no longer rely on speed for safety, though it remained dangerous as a long-range raider and bombardment ship. The symbolic danger of the ship's name was understood immediately. On November 15, 1939, Deutschland was renamed Lützow. Hitler's recorded concern was propaganda. The loss of a warship named Germany would resonate more deeply with the population than the loss of almost any other vessel. The decision reflected symbolism and wartime risk, not a documented official verdict that the ship's hull was physically fragile. Lützow's remaining career was far more active than a simple retreat into the Baltic. She fought in the invasion of Norway, suffered 2 major torpedo attacks, deployed against Arctic convoys, ran aground during the operation against convoy PQ-17, and fought at the Battle of the Barents Sea. Only after repeated damage, machinery trouble, and the changing course of the war was she turned increasingly toward shore bombardment duties in the Baltic. On April 16, 1945, RAF Lancasters attacked Lützow at Swinemünde. A tall buoy near miss tore open the hull and caused the ship to settle in shallow water. Yet she was not finished. Her crew restored power to the after 28-centimeter turret and used the wreck as a stationary gun battery until May 4th, when the ship was finally disabled by her own crew. It was a fitting, deeply ironic resting place for a vessel born entirely from a legal paradox. The victorious Allies of 1919 had used the law as a weapon to suppress a defeated navy, assuming strict tonnage limits would guarantee permanent weakness. Instead, they forced a desperate network of strategists and engineers to invent a revolutionary combination of diesel endurance and welded steel. The Deutschland had successfully beaten the rules of peace, but in doing so, it helped intensify a naval competition that produced enemies its original equation could no longer defeat.